So we're looking at 8.3 notes. This is part 2. We are simplifying complex rational expressions that involve addition and subtraction. What I need you to understand is you're not going to do all of this at once. We are doing several small problems to get to the point where we can manipulate it with a fraction divided by a fraction. So if you look at this, the complex ones can involve addition and subtraction. So last week when we looked at it, we just had a fraction divided by a fraction, and we multiplied by the reciprocal. I cannot multiply by the reciprocal if there's fractions in the denominator or the numerator. So your first goal is to find a common denominator of this numerator. So our first goal is to basically do one simple addition problem, then do a simple addition problem down here, and once we clean it up, then we will deal with the division. So the other thing that's nice about these problems is we're assuming all expressions are defined, as in I don't need you to list me the domain restrictions. So if we're just focusing on the top here, the domain restriction is x can't be 0 or x can't be 2. Okay, and then we'd have to look at domain restrictions of 0, positive, negative, 2, etc. We're not focused on the domain restrictions on this problem. We're just focused on the problem. So first things first, I want to focus on this numerator and build a common denominator. So what would be my common denominator? I'm going to rewrite this. I'm just focusing on the top. 1 over x plus 1 over x minus 2. Okay, what would be my common denominator up here? Can I just put a minus 2 on this? No, I have to build the pieces. So there's no factoring. I'm just going to put this as an x, and I'm going to put over here x minus 2. Now, we want to be careful with negative signs, etc. And then you can write this as you want. I am going to come in with my single denominator of x, x minus 2, and I'm going to clean up my numerators. Now, this one doesn't have a lot going on. I would distribute a 1, and I would get x minus 2 on the left, and I have my plus 1x here. So, big fraction bar here. My final numerator ends up being 2x minus 2 over x, and then x minus 2. Now, you could, I'm going to make this big fraction sign, you could skip this step if you sort of clean this up and got over to here. Okay, now let's focus on the denominator. In order to find my common denominator, I want to factor this. So it's x, and then x plus 2, x minus 2, plus, and then 1 over x minus 2. Okay, so what do they both have? X minus 2. What do they both need? You're right. The right side just needs this. So we're doing exactly what we already did with addition and subtraction, but we're doing two separate problems to build them together. All right, here is my common denominator, x plus 2, x minus 2. And my numerator, I'm going to put a big plus sign here. On the left is just x. On the right is just x plus 2. Now, again, there might be more to distribute. That's why I showed this. Keep my factor denominator, x plus 2, x minus 2. And my numerator is going to be 2x plus 2. Okay, right now we're back to that idea. I'm going to box this in. Right now, it's not my answer, but we're back to that idea that I have a fraction divided by a fraction. So I am not dividing. I'm going to multiply by the reciprocal or keep, change, flip. So as I keep, change, flip, I'm going to factor. This has a GCF of 2. I'm left with x minus 1. My denominator is pre-factored from building it. I'm going to make sure to flip this. So my numerator is the x plus 2, x minus 2. And my denominator has a GCF of 2. And I'm left with x plus 1. Now, if it helps you, rewrite it exactly as you have it and then factor it. Does anything cancel? Any numerator to denominator, since it's multiplication, can cancel. The x minus 2s can cancel, yep. So if you were trying to factor this out and you took out a negative 2, that would make it a negative x. Oh, yeah. So that one doesn't manipulate like that. I can cancel something else, though. I can cancel these monomial factors of 2. All right, so what's left in the top? Yep. And then the denominator? Don't lose that x, and then x plus 1. And then I'm fine with you leaving the factored version of this. You could see that it could be FOILed out to a trinomial and a binomial. And again, we're not focusing on domain restrictions. So one problem is pretty loaded. You're doing two separate addition problems here, and then once you get it cleaned up, keep, change, flip. Okay, look at B. B is a little bit nicer because the denominator is already a single fraction, agreed? But the numerator needs a little adjustment. So what do you want to do?
I would just multiply it by the top one factor.
Okay, so they both already have an x, so I don't need to multiply it by 2x and x. I'm just going to multiply this top by 2. All right, if it's okay with you, I'm going to jump right into it. Well, I'll just rewrite it. Here's 2x. The left is 2 plus 1. So what do I really get? 3 over 2x. And I'm dividing by x plus 4 over x minus 2. All right, so I've got my numerator. I've got my denominator. Do you see now that I've gotten it down to a fraction divided by a fraction? So instead of dividing by a fraction, we multiply by the reciprocal or keep, change, flip. So 3 over 2x times x minus 2 over x plus 4. Now, I think this is going to bother a lot of you, but nothing factors. You can't cancel this x and that x because x minus 2 is a piece. 2 times x is a piece. So nothing cancels. Final answer, 3 times x minus 2 over 2x times x plus 4. So make sure, even though nothing canceled, we put it together as a single fraction. So there's a second method you could do. We could do what we just did where we multiply this by 4 and this by x, and I'm fine with that. The other method you could do is to eliminate the denominators in the complex fraction by multiplying. So if I have, what would be my common denominator between the x and the 4 is 4x, right? So if I come in here and I multiply the top and bottom by 4x, like I say, I'm going to multiply all of this times 4x. And multiply this by 4x. Isn't 4x over 4x the same as 1? But it has to be a common denominator for all the pieces. So if I do that, a lot of times I like to write it on each piece. I'm going to take 4x times 2. That would give me 8, and the x's would cancel. I'm going to take 4x times x. The 4's would cancel, and I would get x squared. So I don't think this method is for everyone. Again, if you look at all the denominators in both the top and the bottom, your common denominator for all pieces would be 4x. So if I take 4x times 2 over x, all I did was cross cancel. Wouldn't this x cancel with that and leave me 8? That's all I did. And then over here, I took x times 4x over 1, and the 4's canceled, and I was left with x squared. So my new numerator is just 8 plus x squared. And the denominator, and again, you have to remember, I'm cross-canceling this. The x cancels, we're cross-canceling, and I'm going to distribute the 4, so I would get 4x plus 4. All right, now that I have that, I can keep, change, flip. So I would keep, I don't need to keep, change, flip. I would factor. Sorry. Does anything factor here? 8 plus x squared over 4 and then x plus 1. Nothing factors and cancels, so that would be my final answer. So again, I sort of showed the work off to the side. If it's truly a shortcut, you're visualizing that changing, but you have to be comfortable to work with fractions. If you didn't like that, that is okay. We could do it the other way, 2 over x plus x over 4 over x plus 1. All right, so if we didn't like that shortcut of multiplying everything by that common denominator, we could just come in and multiply the top and bottom by 4 and multiply this by x, and I end up with that same idea of 8 over 4x plus x squared over 4x. And my denominator stays the same. And I want to show you what happens we would do the numerator as 8 plus x squared all over 4x, right? Cleaned it up. And my denominator is x plus 1 all over x. Okay, this is the point where I would do my keep, change, flip. Keep, change to multiplication, reciprocal, or flip this bottom one. Does anything cancel out? I feel like I have an extra x here. Yeah. So something does cancel, and it should be this x right here, not this one, but this one here. And do you see what's left on the top? 8 plus x squared, and what's left on the bottom? 4 times x plus 1. This is a little more writing. You could probably have skipped this step and gone from here down. This one is basically wiping it out at the get-go, but you have to understand your rules. All right, so either method is fine. You can pick. So let's look at B. If we're using the shortcut method, I need to find all the pieces. But before I do that, there's one thing that sticks out that hasn't come up yet. See that minus sign there? Before you do anything, before you worry about a common denominator, I want to distribute that to the numerator. Okay? Same thing down here. Put this over 1. Distribute this negative sign to everything in the numerator. Now, there are times that maybe you distribute to the denominator to flip your signs, but we like those there. Okay, I'm going to go ahead and rewrite this and factor it. So it's 2x over x plus 4 plus negative x plus 7, watch that sign, over x plus 4, x minus 4. All right, down here, I've got x over 1. I'm going to build that fraction. I've got negative x squared minus 4. That doesn't factor because that negative x, and the bottom is just x plus 4. Okay, if you're doing the shortcut method, I don't want to call it a shortcut, but it is, and you're multiplying out by the common denominator, look at all your denominators. So each thing that we had as a denominator, the least common denominator for all of these would be x plus 4, x minus 4. Agreed? So if I'm trying to shortcut it, I'm going to multiply everything that I have by x minus 4, x plus 4. So I'm going to write it on each one. Maybe that will help see it. X plus 4, x minus 4. I'm going to show it on. So I'm really doing it to the whole top, the whole bottom, and I'm just showing each piece. Now notice this is all in the numerator. This is all over 1 over 1 over 1. X plus 4, x minus 4. Now some of you might be able to like sort of look at this in your head. Okay, that's what I have. Now I'm going to come in maybe with another color. Yes, I don't know if it will show up or not. And I'm going to cancel. So I'm just focusing on each piece. Do you see that the x plus 4 would cancel with the x plus 4 there? So I'm left with this in my numerator. Over here, the whole thing cancels, so that's all that's left. Down here, does anything cancel? Nope, so this is what's left. Over here, x plus 4 cancels, so that is what is left. So I know you might not think this is the nice part, but let's look at what's left. The top has a 2x and an x minus 4 plus, so I don't have to worry about a minus sign, just this negative x plus 7. That's sort of the left and the right. My denominator, all of these are gone on the bottom, but we have this piece up here. We have an x, x plus 4, x minus 4, plus, and then we have this negative x squared minus 4, x minus 4. Again, I chose to deal with our negative sign before we started so I don't lose it. Now I have to clean it up, guys. How you clean it up is your choice. I'm going to clean this above it and say, hey, this is 2x squared minus 4x. No, 8x, right? Distribute 2x squared minus 8x minus x plus 7. So clean that all up. I end up with 2x squared minus 9x plus 7.
Did you happen to find it out?
Now, again, I don't want to rewrite this a bunch of times, so that's why I did my work above and I brought it down. I'm going to do this work below. Now, here's what I do know. I know that the x plus 4, x minus 4 is a difference of squares. I also know that it came right from here. So you could FOIL it out, but this is what I'm going to end up with. and then I'm going to distribute the x and get x to the third minus 16x. Okay, plus I'm going to have to FOIL this. If I FOIL this, I will get negative x to the third. I will get a positive 4x squared. I will get a negative 4x, and negative times negative is a positive 16. Now I did that up above. I'm going to drop it down. I just did it in case there are any like terms to add, but this is what I get for my overall denominator. When I go to add like terms, the negative 3x or negative x to the third and x to the third cancel. My highest power is 4x squared. I've got negative 16 and negative 4x, which is negative 20x, and then plus 16. Okay, before I say I'm done, this is cleaned up. Okay, I canceled it out. We cleaned up the top and bottom. Maybe I'll box this in real quick. This is sort of where we got to and where we went. And this little part was me cleaning up my work. You can do that off to the side. Sometimes people don't show that as much. Now I need to try to factor and cancel. This top does factor, but there's no factors of 7 that add to negative 9. You're going to have to use trial and error. So 2 sets of parentheses, 2x and x. What multiplies to 7? My options are 7 and 1. I'm going to put the 7 here and the 1 here. Negative times a negative. And guys, I picked that because 2 times 7 would have been 14. I wanted a negative 2 and a negative 7. It adds up. Okay, in the denominator, before I factor, I'm going to take out a 4, and then that's going to be a lot easier. So take out my 4, and then factor x minus 4, x minus 1. Okay, does anything cancel now that we've done that? The x minus 1. I cannot cancel that 2 and 4 because that is 2x minus 7. So what's left? 2x minus 7 all over 4 times x minus 4. You don't have to use the shortcut. You could have built each problem out to do it that way. So, in case you are interested in the other way to do this, if I rewrote this problem and I had 2x over x plus 4, this is method 1, I would still have changed my signs. I would still have broken this up. So I would have started everything the same. Oops, that should be a minus 4. My denominator would have been x over 1, and then I would have kept my sign change throughout. Okay, so I basically rewrote the problem and prepped it. This is what it would look like. And then I would come in and build my common denominator. The difference is I'm going to write it on each piece. X minus 4, x minus 4. That's what I needed here. And I'm going to work with that numerator. So it's the same thing. I just have an extra step at the end. My common denominator is x minus 4, x plus 4. I'm going to have to distribute. So 2x squared minus 8x plus nothing changed over here. And so if I want to finalize this numerator, I would end up with 2x squared minus 9x plus 7 all over x minus 4, x plus 4. So you notice that that's the same values we had. All right, now to do my denominator, my common denominator is just going to be x plus 4. So this needs an x plus 4 and an x plus 4. So over here, my denominator is x plus 4 standing alone. And my numerator is x squared plus 4x. And on my left numerator, it's negative x squared minus 4. Okay, so clean this up. It would cancel out and leave me 4x minus 4 over x plus 4. So I'm back to that idea of multiplying by the reciprocal. So I'm going to keep and factor at the same time. I want my 7 in there and my 1 here. And I'm going to multiply by the reciprocal, which the x plus 4 is going to go up top. And down here is going to be 4 and then x minus 1. And so now I'm going to cancel the x minus 1s, that x plus 4, and you can see what's left is 2x minus 7 on the top and that 4 and x minus 4 on the bottom. So if you like this method better, that is fine. Some people like the other method because they're canceling. They might not have written it all out. So when I did this method, I wrote everything out so you could see what was canceling. Some people would just keep in their head and cancel and leave that extra piece there. So this I showed above and below. This one I sort of broke down in pieces. My preference on this problem, I probably would have done it this way, but there's other problems that it's better to do the other way.